So before we start, kind of something funny about the title of this talk and what it's going to be about, where I wrote the talk for an internal talk at HubSpot, and then a few days ago, I read the description on the React Boston website, and I'm like, oh, I forgot that I submitted these things. So I had to go and modify everything to make sure it was actually as advertised. So yeah, large-scale migrations. So a bit about me. My name is Francois. I'm an engineering lead of front-end infrastructure at HubSpot, a company here in Cambridge. What it essentially means is that I lead a couple of teams that do completely unholy things with the front-end ecosystem and write way too many Webpack plugins. So we're going to talk about tools and ways that you can maintain a lot of code. During the last 2 days, we've seen a lot of tools, a lot of things around the React ecosystem, a lot of new techniques, things like style guides, design systems. All things, GraphQL quite a bit too. All things that will help you build features super fast. There's a lot of cool new things in the ecosystem, like Create React app, that let you start from the beginning, again, super quickly. I dare say that it's pretty much easier than ever to build a front-end application. And with how easy it is to generate so much code, you'll quickly end up with a heck of a lot of code, and you eventually have to maintain it. There's not nearly as much, should I say, effort put in that area. Like, what do you do? Like all the documentation, all these tools, they all made it so easy, and then you left me on my own, and now I have to deal with it. As your code base grows, you're going to need to be able to deal with its scale. So let's get started with a bit of a story. It's the story of an evil library maintainer. And if you've worked on a code base long enough, this story will probably be quite familiar to you. And this is going to be my serious piece of software. Now I'm going to ask for everybody to use their imagination. These 5 lines of code, imagine that it's 10,000, 100,000, 10 million lines of code, all similar to this. Code that are using a third-party library that's using its APIs. Unlike the talks from earlier, I'm a cat person. And so I have this third-party library called, it's fictive, myzoo.js. It does not actually exist, at least I don't think so. And it has a named import, animal. I'm going to use the speak method on it. It takes a couple of arguments, a string representing a sound, a target that's not represented in this code. Again, imagine that you have an entire code base doing stuff like this. Our evil library maintainer had an idea for the public API of his library too. I'm going to rename the public method speak to talk. And now I'm using this, thousands of times in my code. Me as the consumer of it, I now have to migrate because I'd like to keep using the latest version. I mean, it's important. It's an important library. By the way, who the hell makes breaking changes in minor versions? But it happens way too much. All right, but it's cool. It's cool. I got this. It's the only thing in my entire code base called animal.speak, and I can just use a search and replace. If that's true when you have to deal with third-party libraries, you're the luckiest developer ever. Anyway, I could do something like this if I wanted to script it. Like I take my source, I replace animal.speak with animal.talk. Here I'm outputting it to the console. I could just obviously overwrite the file. Cool, I got this. And things were fine, but the evil library maintainer wasn't done yet. Another patch release with a breaking change. He decided to change the order of the arguments. The sound and the target are now swapped. That person was pretty fond of like the order of the arguments, maybe for currying or something. And now I have more work to do. My search and replace just not gonna work anymore. Because like, whoops, spoiler. But like the meow or the target could be named anything, so I can't just like search and replace that. But it's okay, I've read XKCD. I know regular expressions. So I could change my script for something like this. I'm not going to go over the regex, but regex lets you can match various groups on your text, and you can easily refer to it afterwards, so I can swap the order of the arguments. That's cool. For this, it's going to work. But these are pretty simple example. Spoiler alert, this is not going to scale. I'm sure many of you have had to deal with breaking changes in third-party libraries that were much more complicated, or with code bases where things, the way they were named or formatted, just simply would not be refactorable with, is that a word? Refactorable with text processing. There could be, like, I could have an animal that speaks that come from another module. I don't want to refactor that one. It's not the one that's broken. I could be shadowing variables. Shouldn't do that, but it will happen. And I shouldn't refactor that one. There's no guarantee that the animal is the same one as the one from my library. There could be weird formattings or weird comments, and my regex from earlier is not going to work. I could make a more complicated regex, but how far do I have to go with this? Given enough time, something is going to go wrong. You could argue that if you're using something like Prettier to format your code or a proper ESLint setup, all the cases that I showed you won't happen. But again, those are just simple examples. I only have so much room on those screens. You can definitely imagine scenarios where it's not going to work. What we need is a tool that understands JavaScript. Text processing is just not going to cut it when I have to deal with code that has specific meaning and semantics, code that could be formatted in any way you could imagine. It's JavaScript. It has a spec. I should be able to have tools that understand it and can manipulate it. So what kind of tool do we actually need? Well, first, it should be a tool that does not work on text. It should work on an AST, an abstract syntax tree. The goal is to deal with an unambiguous representation of my code, where two ways of writing the same thing should just result in the same stuff. Again, it needs to understand JavaScript. There's a bunch of these tools. Babel and Typescript are probably the most popular right now, but there's a bunch of others, Esprima, Flow, Acorn. I mean, I'm not going into popularity contests between those tools. I mean, when you're just trying to look at an AST, not necessarily develop code. So the word AST has been used quite a bit over the weekend, but for this talk, it's actually important that everybody understand what it means. So an abstract syntax tree, you can think of it as I'm going to oversimplify, but an object representation of your code. You're no longer looking at strings of text written for a human to read. It's objects meant for a machine to manipulate and look at and understand. So if I had this import from my code snippet, import a named import called animal from and a source. Well, this is the text that I'm typing. When a parser goes through it, a couple of different ways that it could interpret it. It's all going to be pretty similar because it's all JavaScript and all following the same spec. But this is an import declaration. This is how it's called in Babel. An import declaration has a property specifiers, which has an array of import specifier. It could also have a default import specifier. It also has a property source. That's a string literal, and it represents where the import comes from. These are the pieces that I need to express an import declaration. The spaces, the fact that I'm using single quote versus double quote, the fact that it's on one line, all that is irrelevant. It's just for me as the developer. Once the machine looks at it, it doesn't care anymore. That's what an AST has. That's how it will look at the code, and the tool that I'm looking for should work like this. Next, the tool that I'm looking for should make as few changes as possible. If I was to naively use some of the parsers that I just talked about, import, like read an AST, modify it, print it back out, it's going to be quite a bit different than the original because I just mentioned it doesn't care about the formatting. The tool that I'm looking for should, though. It should only make changes where I want and doesn't touch anything else. We'll have to kind of code review the changes that it made. I'd like the tool that I'm looking for to allow me to write scripts that are reusable, that are fast. I should be able to run them on millions of lines of code. I should be able to share them with somebody. I should be able to be the evil library maintainer making these changes to my library and give it to, let's say, you, my user, and I say run this, and you're going to be able to use my latest version. There's IDEs and editors that are scriptable, and they do provide these kind of features, except then, like, let's say you're using the scripting capabilities of Visual Studio or WebStorm or something, then you have to buy those tools, and that's not great. I'd like everybody to be able to use my script. There's a tool that meets all these criteria. It's called Recast. Now, if there's some of you that have done code mods before, you're going to say, wait, Francois, you misspelled JSCodeshift. We'll get on that later. But let's talk about Recast for a bit, and we're going to write a code mod with it. So more about Recast. It's a tool that's been written by a guy named Ben Newman when he was at Cora. He worked at Facebook for a bit, and I think now he's working on GraphQL and Apollo. It lets you think about your code as an AST. You don't even need to care about the parser and details and stuff. And it will pretty print only stuff that changed. Fun fact, if you use Prettier, the pretty printer of it as its root in Recast's own pretty printer. Now we're going to look at our original problem. For the sake of this talk, it's going to be the simplest one, just renaming a method so that the code snippets are smaller. And we're going to use this tool now that we have the right tool for the job. But we're going to make it a little more difficult. So this is the code snippet that we're going to try to refactor. So let's go over it for a bit. So there's the simple case. It should simply rename the talk method to speak. And the animal named import is in the same scope. That's the easiest case. We're going to put comments that are exactly the same. My script shouldn't touch those. Sometimes JavaScript has multiple scopes. The function could be inside another method. I want those to be refactored, unless it's shadowed. Then it's not the same one. I don't want to. And I'm going to throw some more complex stuff that would make it hard for a regex to deal with. And I'm going to use the example from earlier, where animal that speak come from a different library, and it shouldn't touch that. So let's go through the script. The code is pretty heavy when you look at it at first, but we're going to break it down, and hopefully it will be much easier to understand when we're done. So first, boilerplate. This is not particularly important, but you can look at line 6, where we're just reading the code file. Line 7, just use Recast to parse it. There's the parser options. These are basically the same as, let's say, when you're configuring Babel in a Babel RC. It needs to essentially match. Recast itself has some pre-configured parser configuration. So if you're just using standard code, you can use one of these. So I'm using the one just for modern ES6 code. Then on line 9, I'm just going to visit this AST. So when I put code on line 10 where the comment is, it's going to be like basically processing the AST that I parsed. And then I'm just going to output it. So here I'm outputting it to the console. Now, this is the solution, but before we go over it in details, let's look at a couple of pieces of it. So there's this visitor function called visitMemberExpression, and I'm looking at nodes and their properties and their name, or on line 10, I'm navigating to the grandparent node, and I'm dealing with the import declaration on line 11, the same one that I was looking at in my AST example earlier. If you're like me, you might not be an AST expert. I push text files to the internet for a living. Like, this is not my area of expertise. So, and if I look at the Recast documentation, I'm not going to find a lot of these. The API basically comes from how the AST works. You need to be familiar with it. And personally, I don't want to be an expert in that. So first, to understand, if you were to look at the source code of Recast, none of these functions and things are there. Recast depends on a library called AST Types. And AST Types is built by the same person, and it's kind of a mapping between the parser, like let's say Babel in this case, and Recast. It has all the type, quote-unquote, type definitions of all the nodes that could be contained in an AST. And the API that we're working with is generated from that. It's kind of dynamically generated. As a side note, it's even worse with TypeScript because Babel 7 now can parse TypeScript, and Recast can use that under the hood, which is great. So this is kind of what it looks like if you were to look at the AST types library. This is a variable declaration. So if you look at line 4, variable declaration as a kind, it can be varlet and const, and this is what we could inspect in our Recast visitor. It can like inherit, so it has like a base of declaration. It uses a kind of inheritance system. If you go look in the AST types repo, you basically can learn the language. This is an example of a ternary expression. I'm not going to go over it, but what's interesting is that Recast refers to these in its printer, its pretty printer. So if you looked in the printer.js file in the Recast codebase, you'll see a massive switch, and one of the cases will be conditional expression. It's referring to that AST node. So if you look at that, it's like a ternary expression. It has a question mark with a consequence and a colon with an alternate. It also is wrapping it in parentheses. It's doing that to be safe so that it works in all cases. But like if I wanted to run a script on my code, I wouldn't want it to like go and put parentheses around all my ternary expressions. That wouldn't be great. Well, this is where, if we take a few steps back, I mentioned the tool I'd want to use would be one that doesn't make changes that I don't want. This is where Recast shines. It's only going to call this code if I actually create a ternary expression in the script. If they're already there, it's going to leave the formatting untouched. And since most refactoring I do don't involve touching ternaries, maybe it will touch something inside a ternary, but not the ternary itself. Those parentheses will never make it there. Next, now that we know how it's kind of built under the hood, we'd like a more visual tool to deal with it. There's this thing called AST Explorer. The URL is there on the screen, astexplorer.net. And this is kind of what it looks like. It's a little tiny, I'm sorry. But basically, if I paste the code that I was using for my examples earlier in there, I see a kind of tree view representation of the AST. So here I have my cursor on the source, the myZoo.js part of the import. And it tells me that it's the source property of an import declaration. An import declaration is then part of a program. If you look you squint a little bit, you'll see that it has the specifiers too, the array of specifier. It's not expanded there. It's a tree. So that's basically what we were looking at when I was explaining what an AST was. Both Recast and AST Explorer just use the same parsers under the hood, like it used Babel and stuff. So if you're using non-standard syntax, let's say class properties, you'd have to configure them too, else it's just gonna error out. They both allow you to do it. All right, now that we're AST experts, or rather we know how to use tools to explain to us how AST works, we're going to go back to the script. So what I want to do by renaming the speak method of animal to talk is really, I want to change this line. If I look at it in AST Explorer, I notice at the very first line at the top of the screen that it's a member expression. That's what this kind of method call on an object is. The speak part, which is highlighted in yellow, is a property. So property gets really overloaded. It's a property called property. But it has a name called speak. And then a little higher up, you have the property object, which is an identifier that has a name, animal. So a member expression has that object, that property. I need to look at all of that, and then I'll be able to do my refactor. So first, I'm going to visit member expression. I mentioned the API is basically dynamically generated. Put the word visit in front of whatever you're looking at. I want to look at all the member expressions. So visit member expression. Now, if the property has a name that's not speak, I don't want to refactor it, so I can just abort out of that. Now, the next challenging part, and what will make this more powerful than just a search and replace or regex, is that I will look at the scope. Basically, I want the animal to be associated somehow with the named import, and I want to make sure that it has the source myZoo.js. So normally an AST doesn't have that kind of information. It's just a representation of the code. It does not interpret it in any interesting way. But Recast, as it's visiting everything, it's creating this path object that adds a little bit more information. One of these additional piece of info is the scope. The scope has bindings, and this is where those associations can be inspected. So if I look at the object property of what I'm looking at, and I get its name, so ideally it would be animal, then I can use that path scope. It has a method lookup, and I look it up. The scope has bindings, and I can get one of those bindings by name, and when the stars align, it's going to be the named import, essentially. So it kind of does that association. So if I was looking back in AST Explorer, what I'm going to see when I look at those bindings, that it has essentially like the animal named import is an import specifier. It's part of an import declaration. The import declaration has a source. Again, it's all the stuff that we looked at earlier. I want to make sure that the binding I'm looking at meet all these criteria. If it is, I rename stuff. If it does not, I don't. So this is a bit what the condition would look like, the highlighted code. So if the name of the node that I'm looking at when looking at the binding is animal, its grandparent is import declaration, because if we look, there's two levels there between the yellow on the left. It's import specifier then import declaration, so grandparent. So if I look at its grandparent and it's an import declaration, and then the grandparent source is MyZoo.js, I now know that I'm looking at that kind of association, and it's the type that I want. This is something I can't easily do with a regex. And once that condition is true, I just mutate the node. And this is all there is to it. If it's not, I just do nothing, and I'm just going to keep going. That's basically it. Only the nodes that are modified will be pretty printed. Since I'm changing just a function name that has essentially no formatting, I'm pretty guaranteed that it's not going to mess up my formatting. The rest of the file is completely untouched. Also, things like scope that we looked at are pretty easily handled this way, because Recast does the work for me. All right, next we're going to bring this to the next level. This is a cool tool, but it's pretty low level. The first thing, okay, there's JSCodeshift. JSCodeshift just used Recast under the hood. Recast is doing the interesting part. What is JSCodeshift? Is a toolkit to essentially handle all the common operations that you'd want to do with a code mod script like what we just wrote. You don't want to have to deal with like reading files, writing files. Like if you were to do something like we just wrote, the first thing you do is write a CLI tool that can like take a file name as argument and run it on it. JSCodeshift does that. It also has a slightly friendlier API. So this is the boilerplate we were looking at earlier. You don't need any of this if you're using JSCodeshift. It does it for you. This is a bit of an example of the slightly friendlier API it has. If you're familiar with things like Lodash or like array methods, it can let you find node in the AST, filter them, do kind of a for each on it. The rest of the code, I literally just copy-pasted it. Recast and JSCodeshift are essentially the same. This is an example of what it looks like when you're running it in the terminal. So I'm running JSCodeshift. I take my code mod as an argument. I pick a directory, and it's going to shoot it in parallel over a bunch of workers. And it will tell you how many files have been modified. Next, TypeScript. And here, I'm not talking about using TypeScript in your code. I'm talking about programmatically using the TypeScript parser. The TypeScript parser is actually really interesting. The API is pretty simple to use, and it will work with any valid JavaScript. If you're using Flow, then not really. Flow has other ways to do what I'm going to show you. But if you're just using even normal JavaScript with no file, what I'm going to show you is going to totally work. So this is a problem that the code mod did not handle earlier. If I was assigning animal to another variable with a different name, then I'm not going to catch this. This kind of sucks. What I really want is, let's rename the method speak on anything that's of the type animal. That the name of the object really doesn't matter. The TypeScript parser can help us with that. So this is the condition we had earlier, and it's just a little bit too naive. It only works if like the names and stuff all lined up. So with the TypeScript parser, what can I do? What I could do is take the file and build a program in memory with it. So on line 14, 15, I'm using the API to create a program, get its file back, and then, interestingly, on line 17, I can get an instance of the type checker. And this is what's going to be powerful. If you look at the second to last line there, I can log the source file from which the type of the variable I'm looking at came from. I'm also returning the type. I'm going to be able to do stuff like duck typing. Like if I have an object that has 4 methods, one of which is called speak, and it comes from this file, and it takes 2 arguments and so on, I can inspect all of that. So even if I don't have actual like TypeScript types, I can do a lot of good checking there. So this is how we create the program. And this is where I can, like all the stuff we just talked about comes from. So again, look at line 7 and 8. This is where all the magic is. Now, more interestingly is how I integrate that in my code mod. I'm going to post the slides later so people can look at the code more closely. But this is where it gets really interesting. I put the stuff there in a function, and if you look at the first line near the end, I can get the start position in Recast. It's part of the AST, the start position of my variable. And I can get its file path, and now I can look at the name of the symbol. So even though it's called cat, I can look that it's of type animal because it was a class or something. Has nothing to do with using TypeScript. All right, next, the sky's the limit. This part is the humble bragging part, but since this is all programmatic tools, like you can do whatever you want, you can slap a UI on this. And this is unfortunately not open source, but I still like to show it. It's a tool that we have at HubSpot that wraps all of this to shoot code mods like this on thousands of repos, reports how many success and failures there is. You can look at the patch, the changes they did. Again, like the sky's the limit because you just have a parser and it's giving you what the changes are. There's not a whole lot to it aside the styling. And that's basically it. So I encourage you to try it out. If you're like me, the world of parsers and AST and stuff might be pretty scary. But once you have things like AST Explorer and a good debugger, it's just a tree of node representing the language you're dealing with. It's actually pretty fun. Like I was looking at certain syntax stuff in TypeScript, and I was like, what's the difference between a namespace and a module? And then I toast it in AST Explorer, and it's parsed the same way in a lot of cases. Not all cases, but in a bunch of them. And I didn't know that, but using AST Explorer, I could figure it out. Most importantly, having a lot of code shouldn't mean you can't keep your code base healthy. You can programmatically do a lot of stuff that normally you do manually. 1 million lines of code, 10 lines of code, you just run the script and you're done. Don't let the evil library maintainers ruin your day. Thank you.